Hi, today we are going to study backtracking method and NQueens problem. So, topics that we are going to cover is the method of backtracking, what is the NQueens problem, followed by a solution that is to 4 queens problem and how to generate 8 queens problems solution. Let us start by backtracking method. Backtracking method is algorithm designing technique just like dynamic programming and greedy strategy. A backtracking is also a design or programming technique. It searches all solutions which are reachable from a current problem. What are the problems that are being solved using backtracking method? So backtracking method solves 3 types of problem. Very first problem is decision problem. That means are there exist any solution to given problem or not? Is there any feasible solution of a problem or not? So those problem whose answer is yes or no are actually called as decision problems. Those problems will be solved using backtracking method. Second type of problem is optimization problem. This method is used to find out the optimal solution. For example, for any given problem, if there exists multiple solution, which solution is the most feasible, or I must say it is an optimal solution that can be solved using backtracking method. Third type of problem that is solved by backtracking method is that enumeration problem, to find out all possible solutions of a given problem. Now in these kind of problem there is no as such optimal solution. There exist multiple solution to same problem and each of that solution is optimal by itself. So in that case, if we have to find out all different possible solutions that do exist for a particular problem, we are going to make use of backtracking method algorithm design strategy. Backtracking method is a solution is building a vector. In vector, it adds one value or one component at a time. Now, it will also check that whether this partially created vector will come up with the complete successful vector or not. If this partial vector is not leading to our solution vector, then it will not execute or it will doesn't find out that vector in detail. It uses depth first search with bonding. Bonding function is a restriction function which stops our tree growing in larger size. Backtracking method will be more clear to you once you will study NQueens problem. As soon as we will solve 4 queens problem, the method of backtracking will be more clear to you. So let us start with NQueens problem. For a given n queen problem, there will be n cross n chess board in which you have to place n queens in some proper order. Now this order says that no two queens must attack each other. Now if you have played chess, you must be knowing how queens attack. But if you don't know chess, no issues, I will tell you how queen attack each other. Queen can attack any opponent who is present in a same row, in a same column or in any diagonal. So if two queens that comes in a same row, they will get attack each other. If two queens are falling on a same column, they will attack each other. Even though they are falling on a same diagonal, they are going to attack each other. So we have to place n queens over n cross n chessboard in such a way that no two queens will be in same row, in same column or in same diagonal. That is what the NQueens problem says that. So no two queens must be in same row, column or diagonal. Now this NQueens problem can be solved for 4 queens, 5 queens, 6, 7, 8, 9, 16, any number of queens. That's why it is given name as NQueens problem. So what are expected question for any of n queen problem is that does solution exist for a particular queen problem? Say when I say it is 3 queen problem, is there any solution for a given n 3 queen problem? Yes or no? So that is a decision type of question. Or question may be asked to find out any solution that exists for a given n queen. Say find out one solution of 4 queens problem. Or it can be found out, or question can be like that, you have to find out 5 to 6 solutions, say for example for 8 queens problem. Or you have to find out all possible solutions for say 5 queens problem. That can be type of question. So first question is of decision type, second question is of optimality type, and third question is an enumeration type question. Now let us work with 4 queens problem. If there are 4 queens, the chessboard must be of size 4 cross 4. That means there should be 4 rows and 4 columns. And we have to place these 4 queens over the chessboard such a way that no 2 queens can be in same row, same column or in same diagonal. So we will apply backtracking. Look at this method. We will first put first queen in very first box. So if I put it inside that, my first row will be in attacking position, complete first column will be also in attacking position, and my first diagonal will be also in attacking position. That's why I am not going to put any queen over these red lines because it will be in attacking position. So I will choose another queen in some empty space. So an empty space for queen number 2 is this. If I put queen here, the row, column and both those diagonals will be in attacking position. So are there any space to put third queen? Yes, there is one empty cell. I am going to put third queen in this empty cell. But after putting this particular queen, there is no place left to put queen number 4. This is actually not a correct solution because fourth queen is not placed over a chessboard. So we have to backtrack, that means take back a queen number 3 and try some different option. This step is called as backtracking. Take out our last taken step and try something else. Can I put it in some alternate space? No. So I will go one step back and backtrack queen number 2 because there is no an alternate space for queen number 3. So we have backtracked queen number 2. Now is there any alternate space for queen number 2? Yes, a cell number which is just next to it. I will try to put queen there and see am I leading towards the solution or not. If I put queen here, its row, column and its diagonal will get blocked. Is there any space for queen number 3? Yes, I will put that queen in an empty space. Now it will also block some row, column and diagonal. So again, there is no place left for queen number 4. So what we are going to do in this case? We are going to backtrack our last placed queen, that is queen number 3, and try it in some different place. But there will be no alternate space. If I put queen number 3 in the next box, it will block another diagonal and it will lead to no solution. So there are no different alternate space where I can put queen number 2. That's why I have to backtrack queen number 2 also. If queen number 2 is backtracked, can I put it somewhere else? Now remember one point. Every queen must be in different row so they won't attack each other. So So if queen number 2 is going to shift or put inside row number 2, we had only two options, either in cell number 3 or in cell number 4 of row number 2. There are no other options. So we have backtracked queen number 2, but there is no solution to it. So what we will do? We will finally backtrack our queen number 1. So another option where I can put my queen number 1 is a row 1 cell number 2. So let us put our queen number 1 in some different space, that is row number 1 and column number 2. Now from here we have blocked same row, the same column and both of the diagonals. Now diagonal towards the left as well as diagonal towards the right. Both are getting blocked. Now here, is there any space in row 2 where I can fit my queen number 2? Yes, there is a space in row 2, the 4th cell. At that cell, I am going to put my queen number 2. Now the diagonal will be blocked, the column as well as row of queen 2 will also get blocked. Is there any cell in row number 3 where I can put my queen number 3? In a non-attacking position, most importantly. So yes, in row number 3, cell number 1, I can place my third queen. So third queen is placed, its row, column and diagonal will also get blocked. So for fourth queen in row number 4, do I have an empty cell or non-attacking cell where I can put my fourth queen? Yes, in row 4, cell number 3 is an empty and in its non-attacking position. I can put or place my fourth number queen. So this is the obtained solution of fourth queen problem. Now from this, we are going to build up solution vector. Now solution vector for n queens is consisting of n components. Since this is a solution vector of 4 queens problem, it will consisting of 4 values, that is queen 1 followed by queen 2, comma queen 3 and queen 4. And for each queen, it is clear that they are going to get placed in the respective row. That is, queen number will go inside row 1, queen number 2 will go to row number 2. Similarly, queen 3 and queen 4 will sit in row 3 and 4 respectively. So in this solution, we are not going to write row number because row number is equivalent to queen number itself. Only information that we need is the number of columns. That is, we are going to write column number for queen number 1 as first value. Second value will be the column number of second queen. Third value will be the column number of third queen. And fourth value of vector will be the column number of fourth queen. So the solution vector will only contain column numbers of their respective queens. 4 queens problems, the solution vector will look like 2, 4, 1, 3. So this is my 2, 4, 1, 3 solution of a problem of 4 queens. Now is this only one solution of 4 queens problem? Or are there any alternate solutions that do exist of any queen's problem or n queen's problem? Now, if you look at this chessboard, this is square chessboard. If I am going to flip it out, I will get another positions of the queen. That is at 3, 1, 4 and 2. So this is the another solution of a given problem. So for any n queen problem, there do exist more than one solution. As you can see, for 4 queens problem, there are 2 solutions. Similarly, you have to find out at least one solution using backtracking for each queen's problem. This has to be considered as an exercise. Now look at algorithm for n queens problem. NQueens problem starts placing n queens over different rows. So here we have to call NQueens algorithm from where we have to place a queen. So row is nothing but number of queens which we want to place over n cross n board. So we are actually making this call to place first queen, that is row will be value 1 and n is nothing but, say for example 4 queens problem, value will be 4. For 8 queens problem, value will be 8. So very first call to this algorithm will be 1 comma n, that is row comma n. Now here from first column to the last column we have to check, can we place a queen in a particular row and column or not? So here algorithm can place is actually answering our question that queen will be in attack or not. This algorithm is going to return value true or false as per the calculation of the previously placed queen. So it will check out that current queen in a particular row can be placed in a particular column or not. So, if this algorithm can place is the returning value true, that means we have to set this value in a solution vector. Solution vector is nothing but board named vector. So board of row is equal to column. If this queen is the last queen, that is, if this row is the last row, that means we have already placed the last queen. We have to print our solution vector. That's why here we are printing board. If placed queen is not last queen, then we have to call NQueen algorithm recursively for our next row function. That's why in else part, NQueen is called with row plus 1 and size of the problem is n itself. That means if first queen is being placed, we are going to place second queen in 4 cross 4 board. That will be 2 comma 4. The next queen will be row plus 1 over n cross n board. Now have a look at can place algorithm, which actually we are calling here, which is actually returning true or false based on queen will be in attack or not. So can place algorithm will take two inputs, row and column number. Row number is actually current queen number also. So for current queen, we have to check for those queens which are present in our previous rows. That's why loop will start with I is equal to 1 and goes up to row minus 1. That means already placed queen. If they are placed inside a particular column, then we have to return false because it says that previous some queen is placed in a current column. If that is not the case, that means no queen is placed in the same column, then we have to check is there any queen which is placed in a same diagonal or not. If two cells are in diagonal of each other, they will fit in a formula of the absolute difference between any two cells of row will be equal to absolute difference between two columns of the cell. So if any previous queen is present on the same diagonal, then we have to also return false. Absolute difference between row is absolute of I minus row, and absolute difference between two columns is board of I minus column. If two queens are falling on the same diagonal, then also we have to return false. Now how this formula works, that we will see. Any two queens I and J are said to be in single diagonal if absolute difference between their rows is equal to absolute difference between their columns. What do we mean by this? In this example, my first queen is in cell 1, 3 and second queen is at 3, 1. So take a difference between row number, that is 1 and 3. The absolute difference is 2. Now take a difference between column numbers. This is the third one and this is the first one. 3 minus 1. The absolute difference is also 2. So the absolute difference between row number is equal to absolute difference of column number. They are on the same diagonal. Or consider this example also. Cells are 1, 2 and 2, 3. The difference between row is 1 and the difference between column is also 1. So they are falling actually on same diagonal. So the same formula is used here to check whether two queens are falling in same diagonal or not. If no previous queen is falling on same diagonal, we have to return true. That means yes, we can place a queen in a given row. So this is how can place algorithm is working. It will return true or false after checking whether a current place is in attacking position or not. I hope it is clear to you. Thank you everyone for watching this video. This is Munira Totia signing out.